Good morning, boys and girls. I am Miss Mortara, and today I am going to be your lead teacher today. This unit, all of Unit 2. I'm going to be your lead teacher taking you through this whole giant adventure here. Today we are going to be talking about radicals and getting into square roots and what those are, and even the cube roots. This should mainly still be review from Algebra 1 that you've seen, and you probably played around with a lot of these numbers in geometry. We're going to start by reviewing our perfect squares and perfect cubes. These are numbers that we need to be intimately familiar with in order to do well in this unit, and especially as we continue on in the second semester. We will really get down and get dirty with these numbers when we start graphing radical and equations. Okay? So generally when I'm in class, I have kids start just shouting out these numbers. So if you want to shout out these numbers to your computer screen or your phone as you're doing them, that'd be awesome. But if not, go ahead and you can just kind of follow along with me. But we need to know our perfect squares. A perfect square is when you multiply a number by itself, where you have like 1 squared. 1 times 1 is 1. Oh, I need a pen. 1 times 1 is 1. And 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And usually people are shouting right along. Everybody's all excited in class. They're going to town. 6 times 6 is 36. 7 times 7 is 49. Everybody knows these. 8 times 8 is 64. 9 times 9 is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. And those are the ones that you should have had down since Algebra 1. And most people are pretty good with those. It's when we hit 13 squared. My classes normally start to quiet down just a little bit. But 13, 14, and 15 you should have picked up in geometry. Okay? 13 squared is 169. 14 squared is 196. And 15 times 15 is 225. Okay? You want to write these down, though, especially if you're not familiar with these things. Get these things down in your notes or write them down somewhere, because you will refer back to this page frequently. We are going to say that these numbers, all these numbers I'm giving you right now, are totally fair game on a non-calculator test. If I just said, hey, what is, like say the square root of 225, you should know that's 15 because it's been on our list. Okay? And that goes the same now. We're going to add 5 new ones that you should pick up now. These are ones you probably don't know, but that you need to learn. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. You need to know them that quick, that fast, that easy. Okay? But wait, there's more. Not only do we need to know perfect cubes, perfect squares, we also need to know perfect cubes as well. A perfect cube now is a number when I go, instead of just 1 times 1, I'm doing 1 times 1 times 1. Now, the nice thing about ones is 1 squared or 1 cubed, 1 to the 4th or 1 to the 5th when we get there. Hey, 1 to any power is always 1. So that part's nice, okay? So 1 cubed is 1. 2 cubed is 2 times 2 times 2, 3 times, and so that gives us 8. 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. You want to be, again, very familiar with these numbers here, these 25 perfect squares and cubes, and if you get them down, I promise you, throughout this unit, throughout the rest of the year, it is going to make your life so much easier, so much happier. So don't fight us on it now. Get it down and know where we're headed. All right? Now to do some examples. All right. When we do a square root, when we evaluate radicals. Radicals is the name. Quick vocab here. Radical is the name for this stuff that we're looking at down below here. Okay? This little symbol right here. That is called a radical. The number inside, the 64, is called the radicand. And the number that's on the outside sometimes, like down here, this little number on the outside, is called the index number. So when we might refer to these things at times as look at the radical, or what's inside the radicand, or, what does it have an index number of, we're referring to those 3 things right there. All right? But when I'm doing a square root, if there is no index number, that mainly means there's a 2. And if I'm doing a square root, we're asking ourselves, hey, what times what is going to equal 64? Okay? This is why it's going to be so important to know your perfect squares, because if you go back up here, hey, what times what is 64? Well, if I look at my list, 64, Well, 8 times 8 was 64. So the square root of 64 has to be 8. Okay? Now you might be saying, but Mr. Mortara, I mean, couldn't I also do negative 8 times negative 8? Wouldn't that also give me a positive 4? And you are 100% correct there. That is true. However, when we take the square root like this is called the principal square root, and we are always dealing with the positive one. We're going to have to deal with this minus issue later on down the road when we start solving, and we'll get back to that. But for right now, it is always just going to be the positive number. That's all you need to know. Okay? If I wanted the negative answer, what we're going to do, like on the next one, is we're going to put a negative in front. So the square root of 36, looking up at my list, hey, the square root of 36 is 6. The negative in front just hangs in front, and so that's how I'd get the negative 6. If I want to deal with both of them, if you remember like quadratic formula, we'll put the plus or minus in front. So plus or minus square root of 49 is 7. Okay? And again, notice we're not showing a ton of work here. I did a little bit just for the giggles on the first one. But these ones, we're not going to expect to see a lot of work from you. We just want you to have these numbers down. Okay? Now, next one. Square root of negative 4. Again, we're really going to go back to our definition. What times what is negative 4? Well, we kind of run into a problem here because, 2 times 2 gives us 4. But I need one positive, one negative. I can't use the same number. So we really can't do this right now. And again, back in the day, you might have wrote can't do. You might have wrote imaginary, which I'm going to be okay with for right now. You might have even said, you might even know the right answer is 2i, which that's something we're going to get to later on. I'm going to take, for like this day, we would take anything. Okay? Imaginary, can't do, 2i, I would take any of those. Eventually, later on in this unit, we're going to work towards that 2i answer and tell you where it comes from. But for right now, just imaginary, I would say, is fine. Okay, I've scrolled up here a little bit now. Next now. So same thing with cube roots. Okay, now you got to be careful when we're doing this stuff. Watch out whether we're dealing with a square root or a cube root. All right. But if it's got that little index number of a 3, now instead of saying what times itself is 64, I'm saying what times what equals 64. What goes 3 times? And so when you're dealing with cube roots, you're generally going to come over here and you're going to deal with the cube root numbers over here. Okay? So cube root of 64 is 4. 4 times 4 times 4 is 64. So we say the cube root of 64 is 4. Almost too much there. Okay. Same thing now on the next one, cube root of 8. I'm going to consult my list of perfect cubes. And on that list of perfect cubes, the cube root of 8 is 2. Going with the negative on the inside now, what times what times what is negative 27? Well, with cube roots now, perfect cubes, I can't act like before on number 4 we said we couldn't get this to work. With perfect cubes, I can get this to work. If I do negative 3 times negative 3, that's a positive 9, times negative 3 is negative 27. So I cannot take the square root of a negative number, but I can take the cube root. Okay? When you take the cube root of a negative number, you just get a negative whatever that perfect cube was. Number 12. A little bit trickier now on number 12. This number is not on our list. So now you might want to go grab your calculator and you might want to play around a little bit and just start figuring out, is 6 times 6 times 6 343? I'm going to give you a little hint. It is not. 6 cubed, I'm going to add a few numbers that we're going to need to know later on. 6 cubed is 216. You might go with 7 times 7 times 7, 343. And you're going to find out that, yes, it is. 7 cubed is 343. You might want to add those two numbers to your list. Eventually, you're going to need to know them. Not quite in this unit, I don't think, but when we come back at the end of the year, you'll definitely want those as well. Those will be on your list. Okay? So you might want to start trying to get those down. But the answer to this one would be 7. Okay, so you might be saying to yourself, now, Mr. Mortara, this does not seem that hard. This, I think I can handle this. This unit's way better than that first unit Mr. Naughton taught us. I'm kind of enjoying this one. It seems easy. And you're right. So far, things are not bad, and I think all through today, things will not be bad. I think today will be, in this unit in general, you guys will like it a little better. It's a little more cohesive than our first unit. But things are not always going to be as pretty as they were in the first 12 examples. We come to the next one now, square root of 18. Again, if you go back and look up, 18 was not on our list. Okay? So not every number is a perfect square. What we want to do with these is, this is really some crazy decimal on the calculator, but we want to be able to approximate that crazy decimal. So, if I go ahead and look here, if I think about 18, 18 is between 9, which was a perfect square, that was 3 squared, and, no, it's not between 9, I was going to say 9 and 16, but it's not between 9 and 16. I'm crazy. What are you talking about, Mr. Mortara? It's between 16, which is 4 squared, and 25, which is 5 squared, right? 18 is between those two numbers. Therefore, the square root of 18 has to lie somewhere between 4 and 5. And so right now, we're going to work at getting better at estimating how big that number is. But for right now, we just want to approximate the value of the radical by listing the two integers that the radical lies between. Okay, so I'm just going to say the two numbers that the radical is between. So because 18 was between 16 and 25, that is between 4 and 5. All right, same thing on the next one, square root of 7. That one is between 9 and 16, so that would be between 3 and 4. And we're going to do the same thing with cube roots. The cube root of 36 is between 27 was a perfect cube and 64 was a perfect cube. So that's going to be between 3 and 4. And again, if you need to pause this video to go back up and look at your list of numbers, feel free to do so. All right. Now we want to get a little bit closer. Instead of just saying, hey, it's between 4 and 5 and 3 and 4, whatever it's between, I now want to say, which one is it closer to? Okay. So if I look at the square root of 23, again, 23 is between 16 and 25. But 23 is a lot closer to 25 than it is to 16. So square root of 23 would be a lot closer to 5. Okay? And if I were going to start guessing, I might even say, hey, if I wanted to put a decimal with it, that might be like 4.8 or 4.9. We're just saying which one's it closer to, but we might even start being able to guess a decimal that it could possibly be. The cube root of 100 is between 64 and 125. So it's between 4 and 5. Now, which one's it closer to, though? This one's a little bit tougher. I might have to actually go and subtract. 100 minus 64 is 36. 125 minus 100 is 25. So because the difference is less here, again, this would be closer to 5. And so, again, any decimal I guess, in this case, we're closer to the middle, so maybe I guess like 4.6, 4.7. Okay? But we're just trying to get the integer it's closest to. Basically, today, we're just trying to get some familiarity with these numbers and how big they are. When you see a square root, it's kind of crazy and weird. Know that it is a number, it's a decimal number, and just kind of start to get a feel. To help you, I can't bring up a calculator here, but it might help you to bring up a calculator and, you know, actually find out what the square root of 23 is and get that decimal, and so you can see exactly how big that number is. Okay? You can stop the video and do that at home if you want to. All right, last two real quick, and then we're done for the day. I want to evaluate the following expression: 5 root x if x equals 64. So all we do here is we are going to go ahead and we're going to plug in our number in for x. You do the radicals like parentheses. You're going to do those first. So the square root of 64 is 8. We did that one earlier. And then 5 times 8 is 40. Beautiful. Just like that. Same thing here. Number 23. I'm going to first plug in cube root of 64 plus 64. I'm going to start with the radical. I'm going to do that first. The cube root of 64, be careful. This is not a square root. It's a cube root now. The cube root of 64, looking at your cubes, is 4 plus 64. And then 4 plus 64 is 68. All right, boys and girls, that is day 1. I hope you find that easy. If you have questions, ask your teachers, and we will catch you in the next lesson. See you later.